records as GIS data and talk a little bit about my main project as well. So I want to start by figuring out how to do this. Right click. Yeah. Okay, what's the secret? There's a right and left arrow. That should work. If not, I can do this. Might have to do what?
I think it's can't be.
All right. All right. Is there another way we can do this? Get around the... Well, the forward and back buttons aren't working. There we go. All right, now try it. Is that okay? Okay. So my approach to this is basically that GIS is such a flexible tool that we can use almost anything as geospatial data. And for people who are interested in the past, that means that it opens up a whole world of things that we can put into GIS and do things with, like visualize them and analyze them and so on. So I want to give you a couple of quick examples before I start talking about my big project. This is one that I've used a lot in classes and workshops. It's part of a 1922 map of Orange County, in which the main things shown besides roads are schools, and since it was 1922, they're shown by whether they were white or so-called colored. And churches also, although they're not usually on this map designated by race. And this makes a good example for showing people how to take information that's encoded in a historical map and turn it into GIS data. So you have point data and then you have attribute data. If you were able to then find some information about those particular schools, then of course you could add that to your table and visualize it in a whole other way. Another example is taking archival data that is not in map form and finding what is spatial in it. In this case, you might look at this hotel register and say, all these people who came to this hotel live somewhere, right? So you could start mapping where they live and visualize how many of this hotel's customers come from particular places, right? So you can take this kind of archival data and make it spatial. All right, so now let me turn to my big project, and what I'm going to be showing you is work from my doctoral research, and talk some about how the GIS works in that and what some of the problems were, as well as some of the what I think good outcomes. So most of you will probably recognize what's on the screen. This is a map of cities and towns in North Carolina, and you'll see the really obvious cluster of cities across the middle of the state in a kind of an arc that's known as the Piedmont Urban Crescent for obvious reasons. And you see I-85 drawn through there. But in fact, I-85 is kind of a latecomer. If you look at the railroad lines in North Carolina in 1860, you can see the very same shape already there. And that got me really interested in this as a question. As it happens, I was also reading about the trade between colonial businesses in the east and Indians further inland based on deer hides. And I understood from what I was reading the importance of long-standing routes like the Indian Trading Path, as it's called, or has many other names. The number of very important Indian trails that were taken over and enlarged by non-Indian uses. And this is an example. This is from a 1733 map by Mosley, and you can see the path there. Hillsborough would be about where a little bit north of the Jumping Pig there. And if you had more of the map, you'd see Charlotte area over here and so on. Right. So that is pretty obviously the same direction and shape as the other two things we've just seen, the railroad and I-85. So that really kind of piques the geographical interest. So I set out to answer a research question based on the Indian trading path, based on what I've been seeing. Wanted to know whether that trading path had influenced colonial settlement development in North Carolina. By that, I mean two different things. The pattern of land claims across the state, across the Piedmont in particular, and the process by which towns would emerge from that settlement fabric, if you will, and also the system of towns that became the Piedmont Urban Crescent as we see it today. So one of the reasons that I thought this was doable was that I encountered a small number of images from land grant surveys like this, where the trading path is nicely labeled. And I thought, oh, this is going to be great. You know, I'll get a handful of these and we'll follow them across the Piedmont, and that'll be easy. All right. Well, only a few of them do this. And I also figured out that you would need to see not just the ones that show the trading path, but the whole matrix in order to be able to do some analysis and understand the pattern. Okay, so that was a survey you just saw, and I set out to map surveys because I thought, well, this is where the spatial information is going to be, where the visual information is going to be. And when I say map surveys, I'm talking about sort of the earliest big push of European settlement into the Piedmont that was documented and orderly, had concepts of ownership and land records. Okay, so this is a big data set about land records is what I was interested in. Well, first thing is, you know, you probably know this about North Carolina, that it was a much bigger colony than our state is. Not only did it extend all the way out to the west, but before it was divided up into North and South Carolina and Georgia, it was quite large. And then the original proprietors who were granted this huge colony, most of them were willing to give it back to the crown, but one of them, the heir of one of them, said, no, I want to keep that and get some money out of it. So we ended up with the Granville District, which was essentially a division of that original colony, as opposed to an eighth of the current state, but an eighth of the original colony. And the reason this mattered is because you end up with two different sets of records. Right? You end up with ones from the Granville District, where Earl Granville was granting parcels of land out in order to make some money, and other ones where the Crown was handling it. Okay, but in both cases, you get essentially the same system. You get a set of potentially 4 records, maybe 5, for each piece of land, and that means you start with an entry that is somebody says, I want that piece of land, and it gets written down in a book. The second one is there's a warrant. The land office authorizes a surveyor to go out and survey the land that the person has requested. The surveyor goes into the field, and that produces the third document, which is the survey. And eventually, the settler will probably get the deed, and that would be the fourth document. Okay. A lot of people who have done work with land grants have used deeds exclusively as sort of the final product of this process. The problem is that they can be much later than all the other parts of the process. They could be a dozen years later. So that kind of distorts the temporal pattern of how land was taken up. Here's what some of the surveys look like. The one on the left here is by my favorite surveyor, William Churton. Did beautiful work. You could actually read most of it, and once you get used to it. And his surveys are usually pretty accurate, although he made mistakes occasionally too. The one on the right is James Carter You can see it's a lot less legible, and he's included a lot less detail in his plat. Here we have a couple other examples. Thomas Jones on the top. Beautiful stuff, beautiful detailed drawing. On the bottom, I've repressed the name of who does that horrible stuff, but not one of my favorite ones, obviously, and it's really damaged. Okay, so that's these are by way of example of the kind of things that you have to deal with to do this kind of research. Now, each of these theoretically has a lot of information embedded in it. Spatial information about the shape of the tract, and sort of information about the location, although that's trickier. There was no big cadastral map. You had to figure out where these belonged on the puzzle, so to speak. But I have a lot of attribute information. I have stuff about people, the grantee, the neighbors, chain carriers, and other things. You have dates. You have feature names. Sometimes there's mention of improvement in infrastructure. Right? So lots of stuff there. One of the problems is that a lot of these got lost, particularly in the Granville district. A lot of Granville records were lost. And that means that I had to suddenly start including all the other types of documents. So that raised the complexity level of this as a research project. From starting out thinking I was doing a few little tracks with said trading path on them, to suddenly I'm doing all the records in the whole Piedmont from 1748 when the Granville District Land Office opened to 1763 when the current incumbent of that title died and then the land office closed. So for that time period, I'm dealing with thousands and thousands of records. Okay, so it was a big leap, and that meant that I needed to think about how am I going to record, capture, and retrieve all this attribute data, and some other questions that came up. First one, of course, as I just mentioned about the complex attributes. Second one is about whether you're dealing with the document as your primary object, or you're dealing with the land tract as your primary object. And there's some problems with that because the North Carolina records were separated, whereas previously, originally, all the records for a particular tract of land would theoretically have been together. Somebody came along and said, let's separate these. Let's put all the surveys over here, and all the entries over here, and all the warrants over here, and so on. So it ended up with a big mess. And so if you're working backwards and trying to figure out about the actual tract, you have to figure out which things go together, and that's sometimes tricky. I'll show you in a minute the kind of solution that I ended up with, and how it's kind of problematic. The third issue was how to produce a lot of the large quantity of tract shapes in the GIS. Very labor intensive. You want to streamline that. I'll show you what I came up with. Of course, again, putting them in the right place is an whole other thing where you need lots of auxiliary data to kind of help you figure out where things go. And then dealing with uncertainty. A project like this is rife with uncertainty at every level. It is, in the creation of the records and in how you deal with them and how you put them in the computer and so on. And then questions about efficiency versus historical authenticity when you're under time pressure and so on. So let me show you some things that will answer some of these questions. This is an image from the main input form of the database I ended up with, designed by Mary Rouvain, who now has a PhD in information science. At the time she was a grad student. This replaced several feeble attempts on my part to try to figure out how to structure this stuff. In other words, it took somebody who really understands information and how to structure it to be able to do this. But you'll notice that it has a transcript of the survey text right there, and it has places for a lot of other stuff kind of parsed out so that you can then separate it and search on it and do analysis on it. And it also has the survey pairs over here the distance and angle that define the shape of the track, and the units, right, change and escape. So we'll come back to that in a little bit, but here was the basic idea. At the time that I wrote my dissertation, I had almost 6,000 records in the database. So you can see why I'm interested in streamlining, right? One of the other problems, again, that I mentioned there was whether the record or the track is the object that you're interested in. Because the records, because I had to use different types of records, the record, and because they were separated by the state early on, ended up using the document as the object. But when you map it, the tract is the object, right? So there's a mismatch there. And what Mary ended up doing in the database design was making this little window where I could match different documents together. And that created another ID, like a parcel ID, as opposed to a document ID. And so when mapping, whoops, sorry. But here we go. See how we've got two different IDs here as well as a name, and that represents the kind of awkward solution that we came up with to deal with this problem. And one is a parcel ID and one is a document ID. Okay, drawing them, producing the shapes in GIS. This is a window from a third-party add-in for ArcView. No, not ArcGIS, ArcView. Called data editing, and it was at the time the best solution for working with historical surveys because it allowed you to set historical survey units and put in some textual information there and so on. And it would draw these, and then you could move them around on your map. At the time, I was using, ArcGIS had come in and I was using it, but I went back to ArcView in order to make these shapes using this software. It stores this stuff as a text file, and that sort of little light bulb went off, and I said, oh, you could produce this text file in any way you wanted to. You don't have to do it in their window. And so eventually, what Mary and I came up with was a way to export text from the database, including the survey pairs, so that you could import them into the data editing extension and draw them that way. So kind of a long workaround. Thankfully, there have been a few changes since then. About uncertainty, some people have. Brendan Plew, in particular, has done some work on issues of uncertainty in using historical data in GIS. And this is a table from some of his work where he talks about the different kinds of issues that come up. And you can see that they go all the way across the spectrum. Some of them are inherent in the data because of the way the data was produced. Some of them are subject to the error of the person using the computer. Some of them are issues about you've got this computer system that uses great precision, and yet the surveys were only done to the nearest chain and the nearest degree. So you've got a real mismatch between your historical data in absolute terms and how the computer understands it and represents it. In terms of historical authenticity, historians like to maintain everything the way they read it, right? The way they come to it as data, and not change it to be a more modern form or so on. And I think that's a great ideal, but in this case, it was kind of problematic. This is an example of one person's name. It's spelled, something like 11 different ways, 11 or 12 different ways. And so they're all entered separately in the database. And yet, you have to be able to capture or retrieve, sort by, this as if he were one person, because in fact he was. And so there needs to be a kind of alias table to deal with this kind of thing. Unfortunately, 2 grad students working on this with no database design funding. We never got the alias table built, so this is the kind of thing that can expand your work flow by hours and hours, many hours spent dealing with this sort of thing. For other than people's names, I did fudge it. Like if it was, we were talking about the Yadkin River and it was spelled in 5 different ways, I just always say, okay, it's the Yadkin River. You know, I know what river that is. So I didn't follow this historical authenticity path for all the types of data, only for names. Okay, so in spite of all these problems and uncertainties, I did manage to come up with some stuff. So let's look at some of that. I mentioned the Granville district, and so there was a line that separated the Granville district from the rest of the state, the rest of the colony. And my overall plan was to use this whole Piedmont area here. What I ended up with was this orange part, because it takes a long time to do this stuff. And you know, you come up against deadlines, and so you make choices. And so what you're going to see is essentially this orange part right here. Still hopeful of getting back to the other part. All right, so here's a close-up of that orange study area. You can see the counties: Chatham, Alamance, Orange, Person, Durham, and Wake. And the gray part is what I've actually mapped, and that is they're done by basins, watersheds, because that's usually the way that the documents would describe where things were. They say on such and such a creek or such and such a river. So that's what you're going to see right here. This is an example of coding the tracks by either the kind of information I had or how certain I felt about where I was putting it. That is, the ones that are polygons are represented by my sense of certainty about where I was putting them in space. The other ones are represented by type of shape. In other words, if there was a stream or a river and the survey said, you know, it goes this way and then it goes down the stream, then I drew it as a line, and so that's what you see here, the purple outlines. The point type features are either ones where I have some definite evidence about a tract, I just don't have the survey, the spatial shape of it. I have a location, some location information, but no defined shape. And then the other one is where I can infer that there is a tract based on comments in other documents, but I don't have an actual document for it. So you can see it's kind of a mess, but in fact the only two things you can really get from the data represented this way is that there's kind of a divide here between one group over here and one group over here, which I think has to do with the Neuse Basin over here, settlers coming from the east, and this Cape Fear Basin, settlers coming from Virginia down the trading path. The other thing you can get is this area over here near Hillsborough. I was a whole lot more certain about what I was putting where in that case than everywhere else. But I wanted to get more than that out of mapping this stuff, so what I did was turn it all into points so that I could do some analysis. You'll notice that this square here, that is a 100,000, 12 by 12. It's a very large, lost track of my acres here. It's a very large tract, one of 12 very large tracts that was granted to Henry McCullough as speculation, and the rest of them are further west. But theoretically, when he granted land, the documents would end up in the Granville records, but in fact they didn't always. So it only has a few Granville records there that I mapped, and so I thought that would skew things because I wasn't sure what I had. So I excised that from the rest of the work. So here we have, minus Henry McCullough's tract, we have my first experiment, simple density. You see it's not terribly helpful. So I tried kernel density, and that is a lot more interesting. But I wanted to go further with that. So this was the default 9 intervals, nine classes at equal intervals, and I decided to change that to a smaller number of classes and manually set the intervals so that it would accentuate the places of high density. And this gets really interesting. And when I overlay that with current towns and the roads of the time period that I knew about. The main one was, oops, sorry, but the big one being the trading path. We can see that this is really interesting. Hillsborough was the only modern town that was in the midst of this density of land claims, except for Wake Forest. But that's an interesting point there, because in fact that was a bunch of competing claims to land at the Falls of the Neuse, and Wake Forest was not actually a town at that point. Hillsborough becomes a really important focus here, understanding it as a town that emerged along the trading path. Okay, so that means that I got to the point where I wanted to think about process as well as just the pattern, right? So that was the pattern in 1763, which was the end of my study period. And so that might or might not represent a point in time where you're going to understand really what's going on. So in order to look at the process, I started thinking about how the path might contribute to the emergence of towns, and I came up with this little model where I talk about a nodal site, initial conditions. It has to do with the path crossing a river, a good ford site. And basically this is a way of thinking about people migrating into the Piedmont down the trading path, and what caused them to stop and create a town here. Since that's not our main focus today, I'm not going to spend too much time on that, but what I'm going to show you next is a time series where I look at each tract by type of evidence that I had at a particular time, and I go through year by year through my study period from 1748 to 1763. So here we go, it's automated. So you can start seeing things pop in every couple minutes. And then where you have green entry or warrant, those are going to change, most of them are going to change to purple over time. You see that there are some points in time where Hillsborough really jumps in number of people there, number of tracks, and density. So here we get in the late 50s. There's still not much going on in that Neuse basin, and we don't see much over there until we get just about to the end of the study period. So in fact, when we look at it as process, the importance of this area becomes even more stark. Okay. Looking at sort of a local scale at Hillsborough, we see not only is it an important ford site across the river, but lots of other roads are coming into it sort of as spokes of the wheel, right? So it's quite the hub, if you will. And that's an important point about its development as a settlement. We can also look at urban functions in early Hillsborough, and we see some really interesting patterns in terms of the old roads as opposed to modern, or the town lots that were laid out as the town was formally established. But I did set out originally to think about the whole system. So we're going to shift scales here and go back to that idea. And if we look at the trading path in terms of the trading path and the Great Wagon Road, which was another Indian path, we see that there are a number of towns that emerged really early, and that a lot of them are related to one or another of these Indian origin paths. And that got me to thinking about how this might have evolved into an interdependent system like we have today. And it's partly related, I think, to not only these two paths, but the fact that there was no easy way to get to a port. You had to do a lot of internal moving around within the system, and interaction became really important. So to go review this, eventually if I can get back to all these other parts, then I can test that overarching system-wide theory. I just want to mention a couple of things here. Since I have done this work, is a programmer named David McCorkle in this area who is click on that. He's developed he's putting a lot of the land grants online, so you don't have to look at them on microfilm anymore.
You're about out of time.
Okay. Well, this is the last slide.
It's not showing up there anyway.
Yeah, it's showing on there, but not up here. Okay, so anyway, he's put this stuff online along with the cataloging data and some other information, so that that's available now to people. And the other thing is how much the GIS functions have evolved and ways to customize and so on, so that it's much easier. If you were going to do something like this now, you could streamline it a great deal more than I was able to do. Okay. That's all.
Okay.